Seeking English S.A.T. Workbook, page 406, problem 4, second video. In case I was not totally clear in the previous video, the answer that I thought was correct, and I still think it's correct, is 4 out of 9. That's going to be 4 and then /9 in that little box for the depth of 450 feet. What could be wrong with that? Mathematically, maybe nothing. Scientifically, we got a couple of problems. Most of my training, most of my academic training is as a musician, as a composer, and as a music theorist, as a graphic music analyst. But I'm from a science family, so that got me into a lot of trouble in music school, which is an anti-science environment. It's not unscientific, it's anti-scientific. Try it yourself. Okay, so thinking like a scientist in spite of everything, let's take a look at what could go wrong. What could go wrong is you could approach the problem scientifically rather than mathematically. What do I mean by that? Let's look at our data. First thing, here's this word which in American English is spelled R-I-G-O-R, rigor. What does rigor mean? Rigor means if we don't really know how accurate or how precise these numbers are, we need to be very cautious. Precision and accuracy are not always the same. Precision can be very high, and accuracy, oddly, might not correlate with that. How is that possible, teacher? Well, let's be careful. Look at the distances between these. Temperatures are 150 feet difference. Okay, what if these are just also estimates, since we're just dealing with kind of estimates? Okay. How far off could these be? We're not given any rate of variance for these depths. So what would be reasonable to infer? I would say not more than 75 feet difference. Okay, because otherwise it would be closer. You add 75 to that, and suddenly you're closer to this thing. Right? So I'm gonna say plus or minus 74. Okay, plus or minus 74, plus or minus 74. Okay, plus or minus 74, and plus or minus 74. Okay, is it the same data? Well, sort of. We've qualified it in absence of other qualification because nobody told us how precise they were. Is it starting to sink in with you? Good. Okay. Over here we have a 10-degree number, which could be even before we go look at these numbers. Is going to be plus or minus, I'm going to be generous, 0.4, just to round it off, okay? And these are each going to also be plus or minus 0.4. I might be able to go further than that, but I'm going to be nice because, that's what we've got. Otherwise, it would be a different number, right? That's where I'm going to go with that. Plus or minus 0.4, plus or minus, plus or minus, plus or minus. Oh yeah, this is getting to be a long, messy video. 0.4. 0.4, 0.4, 0.4. Okay, if you begin to accommodate all of these margins, okay, your answer becomes very complicated and it will not fit in that box. It would take you a very long time, okay? And if my father, who is obviously a science teacher, were there watching you do the problem, he might be delighted that you're realizing, hey, I can't just push those numbers through the machine and get something out. That's not good science. He might be happy with that, but when he sees you score on the test, he's gonna have some doubts, as I will have some doubts, as would any of the scientific people in my family have some doubts, and they probably all would wish that you had simply done the problem mathematically. In the meantime, because you also are not really given any means to infer any of these degrees of variance, they put this thing all out of shape. Okay, you can still pretty well cross this out. If it's a little dicey, but you're close enough for government work. You could say that the chances of either of those being the correct depth are call it statistically insignificant and let it go. So it's kind of between these two. But with this massive range, change of temperatures. It would be more accurate to be less precise. Really? Yes. Okay. If you introduce false precision, if you are introducing mathematical precision, which is not scientifically defensible, then you are being scientifically inaccurate, even though you're being mathematically precise. So I've not consulted my father or either my brothers or anybody else on this, but my understanding is that the most responsible answer to this question scientifically would be to say 50%, okay? Because you have these two areas which are of comparable range, okay, and with these comparable gaps, okay. To get a more fine answer than that is assuming that you have more information than you actually can rely on. It's better to pretend I have less information. Okay, if the information is not reliable, it's better to pretend that you have less of it. So my answer would be 1 out of 2. Scientific answer, responsibly would be 1 out of 2. Okay, so if my boss doesn't like this video, I'm going to go ahead and delete it. But I think he's probably going to like it. Okay, this is my most experimental video so far. What you absolutely must not do not use calculus. Okay, because even if these were, I've already explained, these are not precise readings, and I think trying to use calculus to accommodate all of these variances would eat up most of your time on the test. But even if you assume that these are precise enough just to draw a single line, and then get a project from the function of that line, and then break it up into quadrants or something like that. No, don't do it. Okay. A simple reason not to do it, other than the fact that it will probably eat up all of your time, is if you get the correct answer, it's not what they're going to want. It's not going to fit in the box, and you may have been told there is no calculus given to you to work with on the S.A.T. So there's no reason for you to introduce calculus to the S.A.T. If you do that, you're actually going against the format of the test. So this has been kind of a long bonus video, and hopefully you didn't need to see it to begin with. But if you did need to see it, hopefully you have only needed to see it once. Okay, if you need to see it twice, though, watch it again. Okay, what I'm telling you in this video is this is something to not do on the test. I'm emphasizing the value of thinking like, in this case, thinking like a mathematician rather than a scientist. I'm not trying to insult mathematicians, but what they do is different from what other types of scientists do. And I do think mathematics is a kind of science. Okay? It's a math test. Don't apply scientific method when all that is called for is mathematics. Thank you.